Alright boys, I just wanted to show you guys a cool trick. So I've been making the ESC design I was talking about earlier. You can see some of it here. There it is. You got the main MOSFET, which is the big black cube in the back. You can see it doesn't look like a MOSFET as much because I snap off the top tab, which is normally right here. So it just looks like a cube, it's much smaller. I don't think we need that tab. That's just to bolt it to a heatsink, which we're not going to be using. We're using a custom heat sinking solution, which involves the using silicone thermally conductive adhesive to glue solder wick wire to this place that normally connects to a heatsink by way of thermal grease. So this is thermal adhesive instead of grease, and we can glue solder wick braided wire, a couple of them, to this, and then run them like 8 inches long or 9 inches long, and air can hit that and cool it, and that will draw heat away from the MOSFET. And then we'll wrap that around the cooling system, copper piping that has water running through it, and that will draw the heat into the piping. So anyways, we don't need then to have that tab for bolting it to a finned aluminum heatsink. So there it is, and I wanted to show you guys the technique I'm using to get the tab off to reduce the size of the MOSFET, since we don't need that tab. Here's a before and after of a stock MOSFET, and then after. You can see the tabs removed. I used to try sawing it out, but I don't know how I figured this out, but it was a very exciting discovery. Um, I just, I take this locking pliers, vice grips, I'm sorry, just my brain went blank. Okay, you take the vice grips. I have electrical tape wrapped around it so its teeth don't mar stuff as much, which it tends to do otherwise. Um, anyways, you snap it onto the MOSFET's body like that. Nice snug fit. Then you take a pliers. Actually, let me get the other pliers. I like these more for this. I think I used these last time. Okay. You grab it like that. And now just make little tiny rocking motions, real small. You make it too big, you actually break the whole MOSFET. Just real little ones, back and forth. You'll notice it starts to give a little more, a little more. I can show it up closer, maybe. And this is stressing it out at a certain point where it meets the epoxy shell. It's stressing that metal out each time. And the metal's not heavy. And it gets weaker and weaker, more and more stress fractures. And then eventually, this doesn't take that long. Look at that. It comes right off. And it's a real clean break, and it breaks at the same spot just about every time. And you end up with the tab removed perfectly. Look at that. It's such a simple method to do it. Now it could be a little bit, like some rough edges, maybe. Well, there's not even really, honestly. But you could file it down if there were some. But it's perfect. So there we have it. That's my trick for removing the top tabs. These are IRF 3205 MOSFETs I'm using, and they're fantastic. They're 110 amps continuous rated. They can handle like 300 amps pulsed for like a short period of time, and they can handle, I think it's 50 volts gate to source, or drain to source, I mean. And then the gate to source is 10 volts, so it's not logic level. You need to have a MOSFET driver, or you need to have a logic level MOSFET that turns on a MOSFET power supply that provides the necessary 10 volts for the gate to source voltage to reach. Require 10 volts to turn this on. But anyways, I do this to every MOSFET to make it a little bit smaller, a little more miniaturized for the robot. So I just wanted to show you guys that cool trick. Also, while we're at it, you can see here, I'm using all battery tab nickel strips for all my wiring here, even for really tiny surface mount stuff. You can see that little resistor in the middle left, and on the upper left you can see the logic level MOSFET that switches this MOSFET on. And this is all following that 3D circuitry I showed you guys. Oh, and you can see here at the bottom I have the diode. That little black thing you can see right here. The diode's wedged up in there. It's kind of hidden away. It's kind of hidden, but it's in there. And here's the big boy. This will go off to probably the battery and this big nickel strip. So we bought bags of pre-cut nickel strips, which helps. I bought 0.1 millimeter by 4 millimeter, like 100 millimeter nickel strips. They're pre-cut. Bought these on AliExpress or Temu. No, I think I bought it on Temu. And I also bought another size for like thicker use. I bought the 0.15 by 8 by 100 millimeter nickel strips, and they're all cut out for you. And you're able to cut these long lengthwise using just regular titanium rotary scissors. I'm able to cut them lengthwise multiple times if I want to make it a lot thinner, like a lot finer. And I can also cut it horizontally too with these. And these scissors have been working great. They don't seem to be dulling too fast. And I got a bunch of backups. So yeah, that's some of the progress with actually making the ESC. Alright, that's something to look to.